Here we visit the lesson that you missed called Making an E-Nose for Parkinson's. And if you recall, there was a video where Joy Milne was able to smell Parkinson's disease. So we actually started the semester. It was probably our second or third class day that we did that activity. Well, obviously, Joy cannot run around the world smelling everybody, and who would want that job, right? So it made way more sense to go ahead and create an analytical system that could check the sebum and analyze it and then diagnose if the person had Parkinson's or not. So that's their E-Nose, and they published a study on their results, which is what we're analyzing. So first of all, when we do these, we're creating a world, all right? And that's probably part of the hard part of this unit, is that we are creating models. So first of all, I'll go ahead and show the answers, but we'll discuss. So the researchers tested the E-Nose on 24 people, 12 with Parkinson's and 12 without Parkinson's. If the E-Nose did not work at all, it's only as good as random guessing. Then they should get about half of them correct, because only 12 out of 24 have Parkinson's. And so there's a 50-50 shot that each person is smelling has Parkinson's. So we had a 50-50 guess. What proportion of guesses would you expect to be correct? Notice it says the word proportion. And today we're talking about sampling distributions of proportion. Then we would say P equals 0.5. Notice there's no hat or anything. This is the true proportion if the E-Nose doesn't work. Okay. In their first set of tests, the E-Nose correctly guessed Parkinson's or no Parkinson's on 17 out of 24 people. So that's 70.8%. Now, some of you thought it was maybe convincing, but most of you did not. You said 70.8% isn't that much higher than 50%. So we did our own simulation in class. We used a Desmos activity to do that. And you had 24, and these are the results for one class. You can kind of ignore this here. So this is pasted in from the Desmos. So you can see that, yeah, it was about half of you. We averaged about half right, which is what we expected because it was us guessing. So let me add in, this is a model-based simulation based on the model that P is 0.5. We're really just guessing, okay? So that's our model. And we saw that 5 of you out of 27 actually did as well as the E-Nose. So this was a period that was unusually lucky, but we did have some other periods where it was less. So 5 out of 27, or 18% of our class, was able to do as well or better than the E-Nose. So is this result surprising? I'm going to say no, the E-Nose result is not surprising. Okay, because that 18% chance of doing that well or better, just guessing, just based on our simulation. Now, if you actually go in and put in the values, you'll find out that the sigma for the standard deviation for the sampling distribution, and this is the formula that we're creating for our model. We know our proportion is 0.5. Okay, don't use what the sample is. This is P, the true proportion, right? And that should be the mean for our sampling distribution if this is true. Then we can go calculate the standard deviation. Remember, we have 24 patients in our sample. So we put in 0.5, and this is 1 minus 0.5, which happens to be 0.5. And you have 24. Take the square root of all that, and you get 0.102. So once you do that, you have a normal model with 0.5 and 0.102. So we actually ran a simulation with a higher number correct of guesses, and we found that that was a normal model. So using the normal curve, calculate the probability the E-Nose gets 70.8% of its guesses correct for or more by chance alone. Is it similar to the probability that you estimated in question 4? So we're not surprised based on the simulation, but based on the theoretical model, that is kind of surprising. It's actually down at 2%. So maybe it does work. All right, so now let's go ahead. A sample of 24 seems small, so we're going to go ahead and recalculate and run it with a much larger sample of 240 patients. So with n as 240, we need to calculate our new standard deviation, and you should get something like 0.0302. So it would be 0.5 times 1 minus 0.5 divided by 240 gives you that. And I really shouldn't make a note. This is of p hat down here, so I'm missing the p hat. All right, so this is the model on Staplet, and when I go ahead, what's the probability that our p hat is greater than 0.708 when the true proportion is 0.5 and the sample size is 240? It's pretty much 0%. So yes, we are more convinced because the probability is so low that it would get 70.8% correct or higher if it was really just guessing. Now that said, I'm going to say that if I had a choice between using the eNOS and Joy Milne had a much better percentage. But this is definitely progress, and I'm sure they're getting better at it. And as we go along in these units, you're going to learn more about false positives and false negatives. And there could be a lot of stuff going on with this instrument that it's not doing, like 90% correct, right? So it's a good start. We need those. All right, and that is the activity that we did in class. And of course, we also did a free response problem, which the video is also shared in your resources.